going to be talking to you today about the FIDO Alliance and covering a little about how open source fits into this world. Don't need to spend a lot of time in this slide. I think this group is pretty much aware of the problems. Passwords in and of themselves are fundamentally a problem. Breaches, lost revenue, et cetera, et cetera. So, not going to waste time going over all that. In the last presentation, I think you were hearing all about the breaches. 99% of the time, it's someone just getting passwords and reusing them, spraying them. And the thing that we like to say is hackers don't break in, they log in. It's a sad reason that it's so easy to do, but it's a primary weakness. Now, a big reason for that is that the primary focus to date has been on knowledge-based credentials only. That you've got passwords, and then even when you've got things like one-time passwords, well, that's two knowledge-based, goodness me, two knowledge-based factors, pardon me, being used at the same time as opposed to mixing it up. You have the problem of passwords being stored on a server, which means, as again, you've heard discussed earlier, that if the server is breached, then that information is available. And it's highly susceptible to all sorts of different threats, phishing attacks, and so on. So what we need is a shift. So we need to move away from just the knowledge-based factors to something that's more possession-based. So something that you can actually hold in your hand, whether it be a security key like the Yubico key that you just saw, or it's your phone or other physical devices. And ideally one that can be unlocked by the user. It could be a PIN, could be a local biometric, so that you're combining different factors and that are not as susceptible. And on top of that, by using cryptography as the fundamental basis for this, you also mitigate the problem of having passwords that can be stolen off the server. Because you're using public key cryptography, the only thing that's ever stored on the server is a public key. And so if there's a server breach, there's nothing to be stolen from there that can be reused for further attacks. So the FIDO Alliance has been around for about 10 years now. And very simply, our focus has been on simpler, stronger authentication. We're trying to find that balance or find that sweet spot where between easy, or not just between, sorry, where things can be easier to do and more secure. You've got, usability things where you start adding in, the one-time password things, SMS messages, email links, and so on, which do provide a higher level of support or higher level of security than just a password, but they tend to be more inconvenient. And often easier means less secure. FIDO is targeting that spot where things can be easier, where a simple user gesture can be the means for unlocking or authenticating in conjunction with a security key of some sort, and by using cryptography to strengthen the underlying authentication mechanism. So the FIDO Alliance itself, just to give you some idea of the strength behind the initiative, has about 250 members. All the logos that you see on the screen right now represent just the board of directors. And as you can see, we've got phone manufacturers, we've got platform vendors, silicon vendors, financial services. We cover the major consumer platforms, Meta, and so on. It's a very extensive and comprehensive list of companies across the value chain, from the core silicon underneath to the infrastructure to the end user services. And so we have a very rich ecosystem that are all contributing to help develop these standards to help improve authentication across the spectrum, both for the consumer as well as the high-risk security scenarios. In addition to this extensive board, we also have sponsor members and associate members who are involved in the development. We have an extensive liaison membership so that we're working collaboratively with other organizations to make sure that the work that we do complements what they're doing, or perhaps enhances what they're doing, adds value to their work. And this includes everything from other industry consortia to ITU-T and ISO. And we also work closely with various government members to make sure that we're addressing various regulatory and policy issues that come from different jurisdictions. The support from large-scale relying parties, service providers, continues to grow. This is an ever-changing list. It doesn't have PayPal on there. It doesn't have Wayfair. It doesn't have Best Buy. You know, these are, and I emphasize those organizations because they are very much consumer-based. The largest scale problem is in the consumer space, right? That's the largest number of people that can be attacked. And so they're a very, very important part of the problem that we're trying to solve and the solution that we've created in this space. One of the nice things about FIDO is that the underlying support, the underlying infrastructure that enables FIDO is now a core part of all the major platforms, as well as all the major browsers. So if somebody wants to build a relying party wants to build a solution that uses FIDO for authentication, they can safely assume that for any modern devices, the support for FIDO is built into them. So again, whether it's Apple or Windows or Android, whether it's Chrome or Edge or Firefox, Samsung's browser, Safari, they all have the core capabilities built in so that the relying parties can build trusted FIDO2 solutions and have them work in the majority of cases. So I'm going to walk through a little bit here about how FIDO actually works. Now, traditionally, what you have is an end user talking directly to the relying party. They type in a password and it goes over the wire. And then it gets stored. Going over the wire, first problem, gets stored, second problem. In the FIDO model, what we've introduced is something called an authenticator, which is a device. It's the thing that creates the public and private key that are used to authenticate in a secure fashion. Now, what's also unique here is that when the user wants to register with the relying party asks the authenticator to create a key, and this can never happen silently. It always requires user verification. So there has to be some kind of user interaction. It could be touch in some cases, if it's, say, being used for second factor scenarios, but it could also be a biometric, fingerprint, face, palm. There's a lot of various biometric mechanisms out there working with FIDO, and that has to be done right up front just to create the keys. When they're created, the authenticator then sends the public key to the relying party, who stores it. When it comes time to authenticate, the relying party then sends a challenge with a nonce in it to the authenticator. The authenticator first assures that, or ensures that, the relying party that's asking for it is one that it recognizes. If it's not a known relying party, if it hasn't already created a key for it, the authentication fails, which is one of the primary ways in which it protects against phishing attacks. So if you create a key pair for Google and somebody tries to phish you with G00le.com, the authenticator will say, I don't know who that is, and it will fail the authentication. Now, if the authenticator has a matching key from that relying party, it will then sign the challenge with its private key, send the response back to the authenticator, to the relying party. The relying party then will use the public key that it got during registration to look at the signature and be assured that it's the correct thing. Forgot to mention that the challenge is sent. The authenticator then asks for user verification. Again, very, very important that this not happen silently, that this absolutely requires some acknowledgement of the user. Again, if it's being used as a second factor, it can just be a touch on, say, a security key. If it's being used, say, built into a phone or your laptop, typically it'll require user verification, again, fingerprint, PIN, something like that. So once the user verifies, then the challenge gets signed, sent back, the comparison happens, and the authentication is accepted. So there's been a big shift within FIDO over the last number of months. this notion of a multi-device credential. In the past, when you created, say, a key pair with Google on your phone, you would then have to create another one on your laptop, or if you say had an iPhone, you'd create it there. You'd create a second one on your iPad or your Mac. And this created some problems, some user, it had some usability issues. It created a bit of a barrier, some friction for end users. And similarly, if you lost a device, you would then have been forced to go and create new keys for every one of the accounts that you had. So the FIDO standard is fundamentally the same. The flow that I just showed you is exactly the same, but we've now got this notion of a multi-device credential. And there's a couple of capabilities here that are worth calling out. The first is that it allows the credentials now to be backed up and synchronized across your devices. So what this means is if I create my key for Google on my iPhone, that will then synchronize using the iCloud keychain to my iPad. So when I then go to my iPad and try and log into Google, I have that same key available and it allows me to log in. So this creates a much more convenient scenario for the end user. Similarly, if I only say have my iPhone and I lose the iPhone, then using Apple's very robust account recovery mechanisms, I can then restore those keys to my device and not have to go back to every account and recreate them. So this dramatically simplifies the model for mostly in the consumer space, and helps avoid a lot of the problems of having to remember all the passwords, of course. Actually, for those who are already using password managers, it provides a similar experience to that, where that information can be carried from machine to machine. Today, the syncing capability is only works within an ecosystem, but this is just a first step. So, for example, if I synchronize, or if I do it on an Apple device, it stays on an Apple device. If I do, or within the Apple ecosystem, if I do it on Android, it stays with Android. Windows, the same idea. The second feature is this notion of using your phone as a roaming authenticator. And the idea here is that if I've created the credential on my phone, I now want to log in on my laptop to the same site. Instead of having to enter an old username, password thing on that device, I can then use the phone as the authenticator for the account on the laptop. And then at that point, if I want, I can create a new credential on the laptop for simply to simplify the process later. With regard to open source, there's actually a very rich community and a very large set of resources available. I assume these slides are being available so that you'll have access to all of the various links. There's 2 pages of them here. Some of them are actually collections of other links, so you'll probably find some repeated information. I'll point out webauthn.io on this page, not only as a source for open source solutions, but also as one of the best test sites for working with FIDO credentials. So if you've written, if you've written a client, say, and you want to work with it, you just want to experiment, see how it works, this is a great site to go and use as a test space. So as I said, here's the second page. Some of these are open source solutions from organizations. Some are from vendors who've made them available open source. It's a fairly large selection of things. I hope everyone finds this all useful. I was speaking pretty quickly. I hope I haven't gone too far over my time. Thank you very much for having me. I appreciated the chance to speak. Thank you very much.